In this video, you will learn how to enable encryption between SAP Logon client and SAP server. I will also show you how to set up your own certification authority using OpenSSL. Finally, we will configure Single Sign-On based on certificates. We will go through everything step by step efficiently but comprehensively. We are starting from the beginning. I already have an SAP server installed in my home labs. It is a system similar to S/4HANA, specifically ABAP platform trial. It runs on a mini PC for just over $100. You can see how I did it in my other video, so I won't focus on that today. You can easily find that video on my channel. Consider subscribing to it, by the way. I'm starting by installing the SAP-GUI, which is the SAP client. I know this is a completely basic activity that you've probably already done several times. However, I wanted to show what options I used. It may be important to the operation of the program. Besides, the instruction was supposed to be step-by-step, so we'll go through even the totally boring ones. But don't worry, it will only get more interesting later. Of course, I have to highlight the core component, which is the main client program. Without it, nothing else makes sense. But note that in the list of components, we also have SNC Client Encryption 2.0. It's the one that allows you to enable encryption between the client and the server. Yes, it's hard to believe, but encryption in SAP doesn't work by default, and you have to configure it. As you may have figured out, connections without encryption these days are completely unacceptable. Never trust your network. While the program is installing, I'll tell you briefly what our plan is. Once the program is installed, we'll take a look at logging into my Sandbox S4 and see what state the system certificates are in. I'll shortly tell you what each section is for. Then we will generate a certificate signing request for the SNC, which is responsible for logging into the system. The next step will be a big one. I will create a certification authority. Take into account that this part usually does not belong to the basis administrator. While in my opinion, it is always worthwhile to know what is going on in the stages to which we are not usually invited. Especially since this is not rocket science. Once we have a CA, we will sign the certificate of my server. Once it's installed on the system, an encrypted connection will be possible, once we've established a trust relationship in Windows. If you only need encryption, you can stop there. In the second part, I will prepare the system for Single Sign-On. I will install a dedicated add-on, namely SAP Secure Login Client. I will also prepare the client certificate and add it to Windows. We will check whether sign-in without login and password will be possible and what else needs to be done. SAP Logon is already installed. We can move on to more interesting tasks. I'm starting the program. I need to create a new connection because the list is still empty. I add my A4H Sandbox system. I enter the basic data. The instance number is 00. I'm defining a connection to a single application server, so I simply enter its IP address. The next tab is a bit more interesting, and you may not have paid attention to it before. As you can see, secure network communication is disabled, which means that the connection will not be encrypted. We can't enable it yet because the server doesn't support encryption, and this is what we will try to implement. I log into the system in a completely standard way using my credentials. By the way, you may note that the lock in the upper right corner is open, so the encryption is not active. I was able to log into the system without any problems. The first transaction I visit is STUST, which shows the certificates used by the system. The PSE system was generated automatically as a self-signed certificate. It is not particularly interesting. The SNC SAP CryptoLib is still empty, and it's the one that's most important to us because it's used when SAP-GUI logs into the system securely. 3 more PSE are used for communication over HTTPS when SAP is running as a server or client. They are not particularly interesting to us today, but we can discuss them more extensively in another episode if there is enough interest. If you are curious, be sure to write in the comments. I switched to my server's console specifically to the user account SIDADM. I'll show you how to find where these certificates are in the file system. I'm going to USR SAP A4H, next to my main application instance 00. And here is SEC, where all the PSE files are located. Note the access rights, which are restricted to the user only. This is very important for security. Here we have System PSE, SSL Server, SSL Client Standard, and SSL Client Anonymous. There is still no SNC cryptolib, which after all was empty in the STUST. Let's create a new PSE. To do this, I first have to go into Edit mode. Now I click on Create. Here I already have to enter the specifics for the future certificate. I will use the domain name instead of the SID of the system. I prefer this approach because it allows me to use the same certificate also for the HTTPS server, which requires consistency between the hostname and the certificate and the URL. Let's assume that the organization in our case is simply the IT department. Of course, I also give the name of the company where the server runs. After all, it's a very well-known company. Then the country, why not? The RSA algorithm is okay. While I set the key length without hesitation to 4096, the maximum available. This is the only right choice today. The PSE repository is now generating. It does not take too long. It contains a key and a certificate. The certificate is, of course, self-signed, which is not satisfying to us. Why? In practice, in professional organizations, and you probably work for one, such certificates are not used. A certification authority should be used to sign such a certificate. It's a matter of security and a trust relationship. On the other hand, there is nothing to prevent you from asking the company's CA to sign this certificate to make it legitimate. Simply generate a certificate signing request, or CSR for short. This is the CSR. It needs to be copied or saved to a file. The file should be sent to the company's CA for signing. The file has been saved. Let me see, however, by the way, what my new PSE looks like. A new SAP SNC PSE file has appeared on the server in the SEC directory. Using the SAP GEMPS tool, specifically its getMyName command, I can check the parameters of the PSE container. I need to specify the full path to the file. By the way, this tool is extremely useful for many certificate operations and is worth getting to know. It is suitable for admin work and troubleshooting very often. As you can see at the moment, the issuer of the certificate is exactly the same as its subject. This is what is characteristic of self-signed certificates. By the way, we also have information about the RSA key, which is 4096 bits long. Now we're going to tackle something serious. Building your own certification authority. It should be noted right away that this is unlikely to be a task for a basis administrator. However, I promised a complete guide, so we'll go through this stage as well. But if you want, you can skip this chapter. Here's the plan. At the top is always the root CA. This is the most important, best protected, signing only certificates of intermediate certification authorities. In our case, it will be the CA for servers, signing certificates of such devices. I will also build a separate CA for signing end-user certificates. It will issue permissions for logging into systems. One important disclaimer before we begin. Certification authority is about knowledge, tools, processes, top security, and people who understand how it works. We will be using numerous simplifications, so don't take this as a guide to building a professional CA. On the other hand, a CA is just a cryptographic key for signing other certificates, so we'll handle that with no problem. I start by creating a folder structure. One folder for each certification authority. Root CA, intermediate CA for servers, and one for users. I will start, of course, with the root CA. The first step is always to generate a private key. I use OpenSSL and its gene RSA function. The out parameter specifies the output file. I also specify the length of the key, which is 4096 bits. The key has been generated, so the X509 certificate can be created based on it. I use the SHA-256 hash function, the same as before in SAP. No DES means that I don't want the key to be encrypted. Key parameter specifies previously generated key file. Days is for setting validity period, which is 10 years. Quite okay for root CA. The out parameter specifies the output file as usual, which is my root certificate. I specify the country, then province, one of the most beautiful cities in Poland, and of course, the name of my widely known company. The unit responsible for root CA is the security department in my company. A name associated with trust and security. I do not provide an email address. The certificate has been generated. I check that 2 files are available. You can clearly see from the access rights that the certificate is something public that we often share. The key, on the other hand, is something as confidential as possible. The CA root key is the most guarded file in the entire company. It had better not be available online. I will now handle the creation of the intermediate CA for the servers, as I planned earlier. I go to the right directory and, as usual, start by generating the private key. Of course, there is no room for compromise here, so the same parameters are used. This step is very similar to the root CA. But after a while, the difference appears. Just as I did with the SAP certificate, I now generate a certificate signing request. Unlike the root CA, the intermediate is no longer self-sign, only to be signed by the superior authorized center. Once again, I am asked about the country, province, my beautiful city, my company. The servers department is responsible for this CA. A name adequate to the function of the certification authority. No email address. I do not assign a password or optional company name. Signing request is ready. Again, the file permissions allow you to confirm that the CSR is something that is not secret, in contrast to the private key. The CSR should now be sent to the root certification authority for signing. I, however, have everything on one computer. So certification comes down to a single, although complex, OpenSSL command. X509 is certificate type. Request. In to define input CSR file. Days option is, again, for validity period. CA option provides certificate file of signing authority, which is root CA in our case. Obviously, also key of root CA is required in the process, because certificate itself is public. This is the first certificate signed by root CA, so I need to initiate serial numbers. And finally, known out option specifies output file with future certificate. Okay, it's signed. I can check if the certificate file exists. This is the first one. I can list certificate details with another OpenSSL command. I need to scroll up to the beginning. Now this is clear, that the issuer of the certificate is my root CA. Issuer string differs from subject, so this is not a self-signed certificate. Consequently, the generation of CSR and signature process were fully successful. I know this is a rather lengthy process, but there is still an intermediate certificate for users to be generated. This is an analogous activity to what we just did for the servers. But we have to go through it. I will try to do it fairly quickly, already without very detailed explanation of the process. But beyond that, don't we learn by repeating similar activities? Of course, I know that this knowledge is not crucial for a basis administrator. On the other hand, consider that you are free to fast-forward the video and I have to run all these commands, one after the other, with very similar parameters. But yes, I am also learning after all. Wizards also have to learn. I know this may surprise you. So far I have generated a private key. Yes, the secret one that we never share with anyone. It is worth reminding always. Now I enter the data when generating the CSR. Then I have to sign the CSR created by the user's CA using the certificate and private key belonging to the root CA. Yes, the process is already well known. The certificate is ready. We can deal with something more interesting. Let's go back to the SAP-related part. If you still remember, earlier I generated a certificate signing request of my SAP system. Then I took a break to create a CA structure. Now I can sign the SAP certificate using my intermediate server CA. I'm copying my CSR to the clipboard to paste it into a file on the server. It's a text file, so it's easier that way than transferring the file. I use VI for this, and if you don't know it, I recommend my video on useful Linux commands. The CSR file is already on the server. Now I can sign it using OpenSSL to get a valid certificate. Again, X509 is a type. Request. Input file is my CSR generated in STUST. Validity is 1 year, which is good practice for leaf certificates. CA is intermediate CA for servers. Private key of the CA is also required. I need to create serial for the first certificate from this CA. Output file is my signed certificate. Subject looks good according to what I specified in the SAP application. As a safety check, I can still verify the certificate parameters using the OpenSSL command. As you can see, the issuer of the certificate is my server's CA as expected. The certificate is also valid for 1 year, as I stated when signing it. Note that it is always the certification authority that decides what the validity period of the certificate is. Anyway, the CA can revoke signed certificates at any time, as long as the certificate revocation process is implemented. I will now prepare a chain of trusted certificates. What is it? In this case, it will simply be a text file into which I will paste all 3 certificates in turn: root CA, intermediate server CA, and my server's certificate. Logically, this will verify that all signatures are correct. By the way, it will establish our trust relationship at the root CA and intermediate CA level. First of all, I copy the root CA certificate, as before through the clipboard because it is in fact only text. Selecting and pasting. Now exactly the same operation with intermediate certificate. Selecting and pasting. In the end, only a leaf certificate remained to be copied. That is the certificate of my SAP server. The procedure is exactly the same as before. Selecting and pasting. I'll save the file just in case, although it would actually be completely sufficient to copy the contents to the clipboard. I go back to my SAP system. I go to the STUST transaction. I go to the PSE named SNC SAP Crypto Lib. To import the certificate response, I need to enable edit mode. Now I can import the certificate. I paste the certificate chain copied earlier to the clipboard. As you can see, all 3 certificates are there. The subject remains unchanged, while there is no longer an indication that it is a self-signed certificate. What's more, the list of certificate issuers includes my server's CA and my root CA. An additional option below introduces a trust relationship for the root CA. By clicking on any of the certificates, I can check its details at the bottom of the window, just as I did with the OpenSSL command earlier. There is the subject, direct issuer, serial number, expiration dates, algorithm information or fingerprints. Same for the issuer certificate. For him, the issuer certificate is my root CA. However, for root CA, the issuer is root CA, because the highest level is always self-sign, and the trust relationship always comes from explicitly adding the certificate to the list. Obviously, I need to save changes to PSE. I already have the SNC certificate signed and installed, but that's not all. I go to the SNC wizard transaction. To be honest, I'm not a fan of it. I usually configure SNC without it, while it's probably a good idea to use it the first time. Later, you will decide if it is for you. This is just the first step with basic information. I'll move on after reviewing them. The second tab is much more interesting. It shows what parameters of the default profile will be changed. The most important one is SNC Enable, which turns on the secure network connectivity mechanism. However, it is worth noting the 3 parameters above it. These are safe values. They make it so that unsecured communication of any type is still allowed, despite encryption being enabled. The system identification, called the SNC string of the system, is also an important parameter. Other parameters, such as only encrypted GUI and RFC, also avoid forcing encryption. So it can be made clear that we are implementing optional encryption and not forced one. If you're implementing a new system, I recommend forcing encryption right away, if your company is ready for it. If you are configuring an existing system, then you should definitely enable and test first before you decide to force it. The next step indicates that it will be necessary to restart the SAP instance. This is completely natural, since static parameters have been changed in the system profile. I switch to the operating system of my SAP instance. I further start the context of the SID ADM user, that is, the instance administrator. SAP control command. My instance number is 00. The function I call is stop system. The system is shutting down. I have been logged out. I'm checking instance 00 status with function getProcessList. All is stopped. The ASCS instance is also fully stopped. Consequently, I can start the system. The ASCS instance has been already started. Oops, wrong command, but it doesn't matter. The primary application instance is still yellow, which means it is starting. Now everything is green. I can try to logon to the system to continue special operation called SNC Wizard. Of course, my connection is still not encrypted, as can be seen by the open lock in the upper right corner. However, this is only a temporary condition. Let me finish the SNC Wizard first. Again, the start step with a slightly different summary. I can easily move on to the next step by clicking the Continue button. A step regarding Kerberos, which is not the topic of our consideration today. I could probably skip it, but I click Continue. This, among other reasons, is why I don't usually use this wizard. I don't like steps that I don't 100% need. I prefer to focus on parameters and functions that I'm sure I want to configure. It's actually even funny because this is the step regarding SSL certificates, which, however, I can also skip. Because after all, I already have the certificates configured, as you can see perfectly well from the SNC private key section. Clicking Continue will only open the STUST transaction. Here it is, everything in place. My SNC PSE is totally fine, so I can close the window to go to the next step. The final step requires only clicking Complete. I will now do something that in my case is not required, because my root CA is trusted by the system. However, if it were not, I would want the system to trust the certificates issued by my intermediate user's CA. So, I will add the certificate of this CA to trusted list. First, I need to save it to my local computer via copy-paste. I select the contents of the certificate file, I create a new file in Notepad. I paste the contents, and I save to the file. Now I can close both windows to have clear view. I go to STUST transaction again. Next to my SNC SAP Crypto Lib PSE. As you can see, trusted certificate list is empty. I'm importing certificate in lower section. This is temporary space. I select the user's CA certificate. I can confirm that this is the right one. I try to add the certificate to the list, but first I need to switch to edit mode. Now the user's CA certificate is on the list. I only need to save changes. Now my PSE contains several things: server certificate with private key, issuer certificates as a trusted chain, and additional certificate on trusted list, which can be totally unrelated to my company. Remember that tracking the validity of certificates and their renewal is one of the important tasks of the basis administrator, usually because it depends on the division of responsibilities. It's high time I finally set up an encrypted connection to my system. I go into the connection edit in SAP Logon. Of course, I'm interested in the second tab, which contains parameters related to secure network communication. I activate SNC by checking the option. Since this is a connection directly to the application server, not through the message server, I have to specify the SNC string of the system manually. It can be found in the system status, for example. Admittedly, I can't use Single Sign-On for the time being, but I don't mean signing in only by login and password, because in this case it doesn't make sense. I try to log in again and see an error. Peer certificate path not trusted. Why did it appear? Because this is SNC, closely related to SSL, and here the trust relationship is very important. My system does not trust the certificate that the server presents itself with. Consequently, it can't establish a secure context. To fix this, I will add my root CA certificate to the trusted certificate repository of the computer I'm working on. Of course, this makes me copy one more certificate from the server. As always, I'm selecting the content to paste this to local file on Windows. Creating a new file, content pasted. Let's save it. File has been saved. Now I need to find a Windows certificate repository. The program responsible for it is CertMGR. I'm searching for this. Manage computer certificates. This is what I need. It has been started. I'm interested in trusted root certification authorities. I can see that it contains many general-purpose, globally trusted certification authorities. I'll add mine here. I select all tasks and then import. I'm selecting the right file. Here it is. Yes, this is the right store in my opinion. Everything seems to be fine, so I can click Finish. It is imported. Let's see if this appears on the list. Yes, here is my root CA. Fantastic. I can check details of the certificate seen by Windows. Issuer validity dates. Again, issuer with details. And subject the same. So this is self-signed, as expected for root CA. But let's finally log on to SAP with encryption because it's been too long. Success. Great. The The lock in the upper right corner is closed. So the secure network communication is enabled, which means that the connection is encrypted. There is also a warning message that no users with the dummy SNC string exist, but SSO is not configured yet, so this is perfectly fine. I can still log on with user and password, but this time over encrypted connection. The first part of our exercise has been completed successfully. I will cover the configuration of the single sign-on mechanism next. On the other hand, if you only wanted encryption, this is the moment when you can open the champagne. To use single sign-on based on SSL certificates, we obviously need a client certificate. Luckily, I have a CA built, so I can generate such a certificate without any problems. As usual, I start with the private key. The key is ready. Next, I need to prepare a certificate signing request just as I did for the previous certificates. The difference will only be in the signing process. As before, I provide the basic data for the construction of the certificate subject. Of course, not all data is required. I will need one more small configuration file for the signing process. The idea is to pass two parameters related to the fact that it is to be a client certificate. This cannot currently be done in the program options, so it needs to be put in a file. One is NS-cert type equal client. The second one is extended key usage for client authentication. Saved. Now I can build OpenSSL command, X509 for certificate. Request. Days 365 for 1 year validity. Input file is certificate signing request. SHA256 as shortcut function. Then CA certificate specification, which is my intermediate user's CA. The private key must be also used. This is the first client certificate, so I need a new serial. Output is a new file with my signed client certificate. And finally, I need to include my new configuration file. Okay, error related to wrong path of CA private key. This can be easily corrected. This time everything is fine. I can check if I have all required files. There are certificate, CSR, and the private key, so it's okay. However, you need to know that client keys are always distributed in a secure way. Therefore, to transfer the file to the Windows key repository, I need to encrypt it. I will build a container in PKCS12 format. It should contain the private key, the certificate, and also the certificates of the signing CAs. Yes, if it reminds you of anything, the PSE file has a similar role in the SAP. However, PKCS12 is closer to the SSL world. Yes, OpenSSL allows you to create very long commands and you can get lost among the options like in a maze. But that's the end of the road. Now you still have to provide a secure and long password to secure the P12 file. After all, it contains a private key to confirm our identity and it will be transmitted over the network. Now it is time to transfer my P12 file from the CA server to my local computer. This time I will use the WinSCP program. I connect to the server. I find my file. I select the download option. Destination. Uploaded quickly, but it is, of course, a local network and a small file. In the operating system, I have to find the option to manage user certificates. It's important that this time it's the user's certificates, not the computer's, although in older versions of Windows it's the same feature. I select the repository Personal, All Tasks, Import. As you can see, store location is current user. I select the PKCS12 file. This is a password-protected container, so I have to enter the phrase given earlier. Long and secure, as always. I confirm where the certificate should go. Finish Success. You can now preview the certificates. Note that the icon contains a distinctive key, because it is not just a certificate, but the whole set. I can display issuer string and subject, which is correct. The CA certificate has also been imported from the bundle. For single sign-on functionality to work, a certificate in the repository is not enough. You have to somehow inform the SAP-GUI that it should present itself with it when connecting to the SAP server. In the SAP ecosystem, you need another program called SAP Secure Logon Client. I downloaded it from SAP Portal and am just now installing it on my computer. As you can see, it looks like a part of SAP-GUI, but it is delivered separately. Installation is for this noticeably faster than with the whole SAP-GUI. Finished. Now I can find the program icon in the tray and bring up its window. My certificate is visible in the selection list. I will set it as the default for the SAP application. Besides, I will do one more important thing. I will copy my SNC string to the clipboard, because I will need it to configure the user account in SAP. I'm returning to my SAP system. I need to log on using user and password for the last time. I go to transaction SU01 to change my account. Yes, I'm Sapdolf the wizard. It probably is needless to say that the most interesting tab now will be SNC. You can see that the SNC is active on the server, so I proceed to edit my SNC name. I paste the SNC string copied to the clipboard in SAP Secure Login Client. I also enable the option that allows login with a password. Without that, I would be left to rely on SNC alone. Ultimately, of course, it is worth disabling it. I can log out of the system and try again. Full success. I didn't have to enter a password. At the bottom, you can see that Sapdolf is logged in, presenting a certificate with a familiar-sounding SNC string. So we went through the entire setup. I have an encrypted connection thanks to SNC, which has been successful before. The goal has been achieved. However, I will show you one more option. Even as you have SSO configured, you can still log in via password by right-clicking and selecting SNC Logon without Single Sign-On. The connection is encrypted, of course, but I have the option to enter a password. That's all I was supposed to show you. I hope the video was clear and interesting, or at least useful. The presentation is long, but I wanted to show everything step by step, without unnecessary shortcuts, to achieve a full understanding of the topic. Of course, this is just an introduction to your further experiments. Please consider subscribing to the channel so that you don't miss other tutorials related to technical topics around SAP and artificial intelligence. Also, write in the comments what your experience with SSL at SAP is and what you would like to hear about next time. Have a great day.
Hi, it's Fioria. I also recommend subscribing to this channel. I have already done so. I also wish you a nice day. May the magic be with you.